Hello, I'm Duncan. In this video we're going to look at converting Java to Kotlin. We're going to look at some material covered in a book by Nat Price and me called Java to Kotlin, a refactoring guidebook. And we're going to look at some other material as well, some things that didn't make the book. We are going to cover importing a Java project, enabling Kotlin in that project, incrementally converting the Java code to Kotlin, so we have some Java and some Kotlin talking to each other. We're going to look at the code we've got, which is quite procedural. We're going to convert it to an object-oriented style, and then look at converting that object-oriented style to a more functional style that maybe suits Kotlin better. And the exercise we're going to refactor is called the Gilded Rose Kata. You can find it on GitHub, and there are examples in lots and lots of languages, including Java and Kotlin, but we're going to start in the Java version. Okay, I had that checked out, and so I'm going to go to IntelliJ and ask it to open in my projects directory Gilded Rose. IntelliJ has found that there is both a Gradle and a Maven build in here, and I'm going to choose Gradle because I understand that a bit better. I'm going to test the project. We download the internet for a few moments, and then we will have some code that we can see and run. Just have a little look around. You'll find that we have Gilded Rose here, which is a class, a Java class with a large chunk of very procedural code in it. It's very confusing, it's very hard to understand, see what it does. It also has an item class, which is quite a bit easier to understand. Basically just holds data. And we have some tests, so let's try running those tests before we do anything. They fail, let's have a look why. You see here it says expected fix me was foo. Looking in the code, there's a foo here and a fix me. So I suspect this has been left to give us something to do. So let's try that, run the tests again, and everything passes. That's good. So maybe that's a good place to check in. We've imported into IntelliJ, everything's working. So let's commit that with fix test. Commit. And really every time we commit, I'm going to take a little break. So this is divided up into chunks that I can edit together later. Right then, now let's have a look around at the other test, because this one really isn't teaching us much about the code. Here we have some code that creates some items. You can see they've got magical names. Creates an app with those items, and then through a loop it outputs things about those items, their name, their selling, their quality, and then asks the app to update the quality. So the premise here is that we have a number of items in our stock, and those are degrade over time in some sort of way, in different ways of different items. That different ways are expressed in this horrible piece of code here in update quality. So we'd like to know that we're not going to break the code as we refactor it, but this is just a main. We can run it, and when we do, it outputs, there we are, the way that items evolve over time. But that's not an automated test, and we don't want to keep on looking at this and trying to decide whether it was the same as it was last time. So what we're going to do is we're going to try and find a way to make sure the output is the same every time, rather than looking at the screen. This is designed actually for a test framework called text test, I think. Test fixture. But what we're going to do is, instead of pushing out to system out, we're going to refactor here, and we're going to say make that a field, in fact make that a variable, make that a variable, and instead of printing to system out, we're going to print to a print stream of our own choice. That print stream is going to be new print stream, and our options here are not very helpful. We can print a string, well, not strings, but files, basically file here, but also an output stream. So if we were to have our own output stream, we might be able to capture the output, and the thing we're going to capture with is a new byte array output stream. Run that. And now we don't see the output because it's hidden inside our byte array output stream. But if we remembered the byte array output stream, then right at the end here we could do and you would see that we get the output that we had before because it's captured inside this output stream in a byte array. Now we've done that, we could, instead of running this as a main, we could run it as a test. It would have to not be static. And we'll just call it a test. Let's run that. Now we can't run it because we've removed the test annotation, so we will run this IntelliJ again, and it now complains that we can't pass string arguments into a test method. Again, now we don't have any arguments to talk to, so we'll delete that. Okay, we are now at least running as a test. Now what we're going to do is we're going to say if we had some expected output, and let's punt on what that is for now, then instead of printing it out here we could say assert equals expected to be this thing, what we actually wrote. We can import that. And now run it. And now we fail, but we fail in a way that we can see what went wrong. And what went wrong is that we expected there to be an empty string, but there was actually this content here, which is good for us because we can now copy that and put it into here. Notice that IntelliJ breaks the string up, run it again, and now we have a passing test. So what we've done here is we fixed really what we expect this output to be. If we were to change something in our input, for example, that would change a thing in the output, and our test would fail. But if we make everything better, it passes. Now 2 days probably isn't enough. These items change over quite a bit of time. They go up and down having read the spec. I think 10 days is enough having read it. So we're going to just approve 10 days worth of output rather than just 2 days. We take all of this, copy it, put it in as our expected output by pasting in there, run that, and that passes. So we now have 10 days of changes. We can see the way that items evolve over 10 days, and this should be a reasonable backstop to make sure that we don't break things as we refactor our code. Okay, that looks like a good place to check in, and this is we're going to call make test fixture a test. Commit that, and we will take a little cup of tea. Okay, So now we've got some tests. Seems like a good time to go and convert something to Kotlin, because we're here to look at converting to Kotlin. Gilded rows we could convert, but I don't really understand what this is doing. I'd like to pick the low-hanging fruit first. Item, though, item does look really quite simple. Looks like a dead cert for converted to Kotlin, where it'd be shorter. So we are going to say convert to Kotlin. Convert Java file to Kotlin file is IntelliJ action, but we don't have any Kotlin in this project. But again, IntelliJ is happy enough to solve that problem for us. We're going to pick Kotlin 1.6. And let's just take a look at what changes that made. So it brought in the Kotlin plugin as well as the Java plugin, a Kotlin runtime library, and messed around a little bit with some options to tell the Kotlin compiler what Java version it's targeting. Okay, so far so good. That looks like a good place to check in. Add Kotlin to build. Bunch of warnings. Let's just see what they say. Oh, they are around versions of things which I don't think we'll worry about, and something about Gradle that I don't understand. So we're going to commit anyway. That's good. And now we can go back to item, try again, convert it to Kotlin. And at this point, IntelliJ is a little bit brain dead. IntelliJ edited its own Gradle file and then didn't notice. So if we go off to the Gradle window here, refresh this, you'll see that we get messages around Kotlin, which at least suggests that we're doing the right sort of thing. And now try again. Convert to Kotlin. IntelliJ now offers to convert other Java to Kotlin in order to fix things up. Normally this is a good idea, so we'll say yes. Okay, there we are. It was that simple. We'll run. Takes a little bit more time to run this time because Gradle has to catch more things, but actually it doesn't even compile. So what's going on here? Well, what's going on here, if we look at our old item.java, is that the name, these fields were public fields and accessed directly rather than through getters in Gilded rows. So here we can see this says just .name, this is accessing the field directly. When our item was converted to Kotlin, these vars generate both a field, but a private field this time, and a getter. And so really the converter isn't clever enough to know about public fields. To be fair, they are a little bit rare in Java usage. We could go forward or we can go back. I think what we're going to do here is we're going to go back. We're going to say roll back that change. And now in order to solve our problem, we are going to in item that I've lost, we are going to make the Java code use the getters, well, use getters we don't have yet, which will suit the Kotlin conversion better. So we're going to say Alt Enter on here and encapsulate the fields. Helpfully we can encapsulate all three at once, and this would generate getters and setters for us. Not only will it generate getters and setters for us, but it will call them in here. So it will update this code, all the code that needs to reference those, was referencing those fields. That should continue to pass its tests. It does. And now, having done that, we can convert this Java to Kotlin. And now we will be using the get name that we have introduced. I think we're going to commit that before going to have a look at it. Just to give us a place we could go back to. 9 warnings, a whole bunch of invocations of get name, which we won't worry about for now. Looking back in item, you can see though that now the conversion is really strange, to be honest with you. Not IntelliJ's finest hour. Let's put the parameters on separate lines so we can see them. So first of all, we have a constructor and separate properties, which we then initialize in this init block. That's not a good pattern, certainly not required here, and I don't know why the converter did what it did. And also the converter now doesn't know that this name couldn't be null. I'm pretty sure it can't be null, so we're going to just go ahead and remove that null. Nullability. But we can't. Okay, let's try that. Okay, so that still passes our test, suggests we're doing things in the right order. And now we should be able to move these into the constructor. It's not clever enough to take the other ones away, but that's okay because we can do that by hand. And now these are constructor parameters, but vars in constructor parameters, these properties, we can remove this init block. Looking sweet. There is a problem that these are variable, and you'll see that later on that that's important to our algorithm, but actually the names never do change, so I'm inclined to say let's just make that a val so we have some steady ground to stand on. Okay, that's good. Those changes won't have affected the Java code, so the Java code is still happy, but we now have a class in Kotlin. One more thing, you can see that IntelliJ is offering to convert this string concatenation to a template. That's good for us. I think we can make this just a little bit shorter by making that an expression body and even removing the return type there. Still passes its tests, and I'm inclined to say this is an amend commit because we have just finished the job that we said we were doing before. Okay, time for a little cup of coffee for me. Okay, we're now going to use refactoring as a way of understanding the code. We have this Gilded rows class here, and it expresses the it works because our store works, but it's really impossible to see how it works. So we'd like to tease out what constraints there are, how it works in some sort of way. And I think the first thing that we might do is just sort of simplify this Java code. We're not going to convert to Kotlin yet, we're going to simplify. And when we look through this, everywhere we're talking about items I, items I, items I, items I. And that's just noise. So IntelliJ is actually offering to replace with an enhanced for. And you see that helps a great deal. Now we know there's a single item, we're only ever looking at that one item, the item at item I. Oh, redo that. Okay, that was a help. Now it would be good to know whether or not whether items, the way they change depends on other items. So we might say, well, what if we took all of this, have we got enough of it? No, there's more. All of the stuff inside here and made a method out of it. IntelliJ says extracted. We'll call this update. Now, that if we pull this out and make it static, for example, then if we can do that and still compile, then we know that item doesn't depend on any of the other items, doesn't depend on any other state here, and that's good for us. Now, what else can we see? The things that are getting in our way here, we keep on saying item get name. So let's ask the question, can we make a variable out of that? There are 8 of them apparently. So that's our name. Does that still pass? It does, that's good. And now we see we have quality. So let's see if we can do the same thing to that. Replace all 14 occurrences of quality. So we get the quality out the front. But now our tests are failing. And if we were to look at how they fail, you see that things were going well until day 3, but then HBRE started going wrong in some sort of way, and the conjured manna cake went wrong in another way. And what the problem here is that we keep on asking the question, what is the quality? But previously we were updating the quality in one place and then reading the updated version, whereas now we're just reading the version as it was at the very beginning. So it turns out that we can't extract quality from here. Can we extract the cell in? No, we can't. Find the same problem. There's an interaction between this is updated and then read, so that we can't remember its value from earlier. So we'll undo that. Run. Okay, so at this point we've sort of understood some of the constraints, some of the ways this code works by trying to refactor it into trying to remove some of this duplication. I think we're going to go ahead and just convert this into Kotlin, because there's a trick that will help a little bit once this is in Kotlin. Maybe we should have checked that in first, but I'm reasonably happy we could just back that out. Okay, irritatingly again, the conversion has failed. And in this case, you can see we had this Gilded rows test that asks for the app items, but we had the same problem with getName. Basically, this was directly accessed in the field, and in this case, I think we're just going to go and fix it up by hand. There's only one of them, rather than all those ones last time. And also, for some reason, we can't create a Gilded rows. Don't know why that was made internal. Fix that. Okay. Now our static function update has been moved into a companion object. In Kotlin, it would be unusual. That would be unusual, really. So what we're going to do is we're going to take this and move it out into the top level of this class, like that. That passes nicely. And now everywhere inside this update method we're talking to items. So we're talking to item name, item quality, item sell-in, and so on. That's a bit of a pain, bit of noise, but we can convert this parameter to receiver to make this into an extension function. And when it's an extension function, inside here, this is the item. So now if we compare where we had said item name, with this change we can just say name. We can just reference that. And that's the same as writing this.name, which we might do sometimes. It'd be the same, but we don't need to. So run that. And this is nice for us because it makes it look as if we have an operation on item called item update. It looks as if we have an operation on item. We don't really, we have a static function, but that's a stepping stone to moving this into item perhaps. So we're all running. One more thing is in Kotlin, 2 classes in Kotlin. So this is going to be convert Gilded rows to Kotlin. And a little bit of refactoring on the way. Splendid. Take a little break. Now, there is a rule in this kata that we haven't talked about. So let's just go down and see what it says. The requirements. It talks about how things work, the sell-in, the quality, and the fact that we lower the sell-in and the quality every day. It talks about how different items actually work. We don't need to know that yet, maybe. But down here there's some small print, and it says, feel free to make any changes to the update quality and to add any new code as long as everything still works correctly. However, do not alter the item class or item properties, as these belong to the goblin in the corner. So, well, we have sort of changed our item class. We've converted to Kotlin. We've made this immutable, whereas it wasn't before. But I think we might get away with saying we haven't really changed it. But maybe we shouldn't add methods to it. So we've seen from Gilded rows here that it seems logical there's an update method. So let's just take this for now and move it over to where item is. And we'll have to make it non-private for Gilded rows to see it. In order to add operations to a type without changing the initial type, we could subclass type. So we could say we've got a class which is BaseItem, which extends from item. And if we do that, then we can add the constructor parameters. I don't know why these are defaulted. I don't think there's any help to us really, so I'm going to take it out. Take it out of here too. Not the best edit. Reformat to sort that out. And now IntelliJ complains that item isn't open, so that's alright. So now we have a base item. It's unused, so our tests continue to pass. If we wanted to make use of that base item, we should create base items rather than items everywhere we're doing things. Let's go back to our Gilded rows, the test we're actually using, this one here, and we'll select all these calls and make them base item. That shouldn't change the behavior because there is no special behavior in base item yet. I'm going to move this to the right so we can see both things at once. But now we should be able to take this update function and make it into a method on base item. Has that gone too far? Not far enough. I'm just going to take it from being an extension function and put it in here. I think there used to be a refactor to do that, but I can't find it anymore. But we're no longer an extension, we are just a method. But we're still uncalled. Why are we uncalled, and why? Because as far as Gilded rows is concerned, these are items. This is an array of item. So we're going to be a little bit cheeky, and we're going to say if item is base item, then we want to call item update. Otherwise, well, that's an error. This will go away eventually, but for now it will keep us honest. I'm going to say the error is that item is not a base item. We wouldn't want this hanging around our code base all the time, but for now it will do. So that's passed. We now have the ability to, we're now creating base items, and we've got a place that we can modify behavior. And we're groping towards an object-oriented solution. We are sending a message to an object in order to ask it to do something to us for us. Okay, that will commit. So this is going to be move update to method on base item and breathe. Okay, now that we have a class we can work in, we can look at this update method. I don't think we need to worry about anything else for a little time. Let's put this away, and we'll just look at item. When we look at item, we see that the update method involves asking a whole bunch of questions about the name of the item. So if it's aged brie, we do a thing. If it's not aged brie and it's not backstage passes, we do a thing. Sulfurous is another thing that affects, another name that affects what we do. Backstage passes comes back, sulfurous comes back, brie comes back, and so on. So we can see that there are 3 special types of things: aged brie, backstage passes, and sulfurous. And we are affecting what we do by the name and not the type. So we think that we might be able to solve some of our problems in object-oriented sense by sending messages to things of a different type rather than just asking for their name. So let's pick one. We'll start from the top, and we'll start with aged brie or backstage passes. So you see here we're saying if the name is not aged brie and the name is not backstage passes. So we seem to have separated our space here into brie or backstage passes or everything else. What I think we'll do is we will take this whole part of our algorithm. We don't really know what it does yet, but we are going to make a method out of it anyway. And we're going to call that method update1. Don't know what it is, that will do. So having got update1, IntelliJ has seen that we're passing name into it. I don't think we need to pass name into it because name is available. So let's just delete that. And if we do there, we could have refactored that a bit better maybe. But that should be fine. Now update1 gives us a place that sort of point of inflection, a place that we can change our behavior. So what we're going to do is we're going to say let's start with maybe aged brie, and we're going to say that we're going to copy this method into another class. What does that mean? Well, that means that we're going to start with we're going to say that we have a new class, and that class is brie. And brie is like base item, but it's going to be slightly different. And our problem here is that base item is currently final. Wouldn't have been in Java, but in Kotlin, classes are final by default. And we'll see how we might get that behavior back later. But for now, we're going to open up base item. Okay. Now, in base item, in aged brie, in brie, we want to copy this update method as well. So we're just going to copy this wholesale. Oh, not cut though, copy. And we want this thing to be called in place of this, so we're going to say that this is an open fun, and that this overrides it. But now, because this is the same code, we don't expect the behavior to have changed. In fact, the behavior won't have changed because we're not actually using brie at all. So let's see where we could use brie, and the answer is we could go back to our test, this one, and in the place where we do brie, we can say this is brie. And as discussed, that passes, and it passes because the code in here is just a copy. Now, when we're in Brie, though, we know that the name not equals to age Brie is false, because the name not equals to age Brie will be true for Brie. So we can just change that to true. We know that that is false. Here we know that this is our name is not that, so that's true. Here we know that our name is not backstage passes, so that's false. And if we're right and run that, we'll pass the tests. So we were right, that's good. And now IntelliJ will simplify this for us. We can just go through and take out all the things that can't be, couldn't be true of Brie. That's really rather good. So we knew that Brie was special. Let's say that we also know, well, now having done that in Brie, we know that this here in update 1, this name is not equal to age Brie is always true, which allows us to simplify that. Okay. In here we now have backstage passes, so let us pull the same stunt. Duplicate this. We're going to say that this is a pass, and we want not the Brie version but the base item version as our starting point. That needs to override again. Run. We seem to have one too many brackets, and the behavior's not changed. It can't have changed though, because we didn't really change this to be a new pass. There are 3 of those we've got to get right, and we think this should pass. It does. Pass passes. And now we can go through the same. These are a bit confusing, and they continue to be, because they are always asking questions about not, so we can ask IntelliJ to invert the if condition. That made a big difference. So, in the case of a pass, name equals backstage passes is true. In the case of a pass, name equals backstage passes is true. So now we can simplify. Where were we? Down here. And simplify. Splendid. And in our base item here in update 1, we had the same thing here. We know now that the name is not that, so that this is true. And we know the name is not that, so this is false. Now we can delete the whole expression. Now we can simplify that. So now we're left only with sulfurous being a special case. Still passes the tests. And we'll have one more little go at this. So we'll say there is this class of, who knows how you spell sulfurous. And we'll copy all of this code. And then we'll copy this. Say override. Now we'll go to our tests and say where you create sulfurous, we need to create a subtype. Check that works. And it does. And now in here, in sulfurous, the name not equals sulfurous handwriting class is false. Delete the expression. Now we've got nothing left. So now you can see that sulfurous update 1 is just an empty block. Reformat. In BaseItem, name not equals this is always true. Simplify that, and we can see that in base, whatever update 1 does, in BaseItem it reduces the quality by 1. In Sulfurous it does nothing. In Brie it updates the quality, makes it larger, and in Parse it does something complicated that we don't yet understand. That looks like a good place to take a little break. Oh, just before we do, worth saying that we wouldn't want clients to call this, so we're going to make it a protected function. So that's a way of expressing that it is only used by our update method here. Check that works. So what have we done? We have introduced subclasses and update 1 method. Good. That really does feel like time for coffee. So you can see a pattern here. We had these 3 if blocks. We've done one, let's do another one. This should be quite simple though, because you can see that we only have one subclass, one special case here. We're going to call this update 2. And we had the same thing with the name, so let's just remove that. Do it the proper way this time. Command F6 then. Remove that. Continue. And run. Okay. Now, the only special case is in Sulfurous. We're going to make this protected and open to allow us to do something with it down there. Copy it, put it into Sulfurous, called update 2. That needs to override. Doesn't care about being open. We've already created all the subtypes we're going to create. Name is not equal to that is false. So we have an empty update 2 block. What does update 2 do here? Name is not equal to that is always true for everything now. And so you can see what this is doing is it's reducing the sell-in time, the number of days until we need to sell the item. And I think that gives us a clue. We might actually call this age. So not quite sure what update 1 is doing, but update 2 is aging the item. Okay, we're on a roll, so we're going to take this code and make it update 3. I wonder whether we can not have that parameter at that point. No, turns out not. So that's okay. Remove the parameter now. Make this a protected open fun, and you'll see that it does different things for all three of our subtypes. So I'm just going to move it into order here, and then having done that, we're going to paste it into here. Override fun, and then that's the version that all subtypes need. If we run a test, they should pass. Okay, and then going from the bottom up, this one is pass, so and we're back to negation being hard, so we'll say invert the if condition here, and invert the if condition here, and invert the if condition here. Okay, so this is a pass, so this is true. This is false. And this is false. Simplify, delete. Okay, check that works for us. It's happy and passes the tests. Now we got to Brie. In the case of Brie, maybe we should have done that invert earlier, but in the case of Brie, this is true. In the case of Brie, this is false. And that is true. Simplify, simplify, simplify. That works nicely. Sulfurous, where we can cut to the chase and see that actually sulfurous does nothing in this case, as it does in all other cases. So that's good. And then finally up in here we will go with our inversions. Our name is never aged Brie. Our name is never backstage passes. And our name is never sulfurous. Delete, simplify, simplify. Okay, so now all of our variation is expressed in these different protected methods. What happens to age, what happens to update, update 1, update 2, whatever these things are. The variation in the different types is expressed in protected methods, and we have created some are still base items, left alone to whatever the default behavior is, and others are items with special behavior. So now we've introduced update 2, age, and update 2. That's good. We are getting there. Now we're going to return to item and really see now whether we can make semantic sense of what update 1 and update 2 is doing. So age, we know, only updates the sell-in time. Update 1 here is doing a thing. Update 1 is always reducing our quality, and then it's reducing it some more after the sell-in date, when sell-in is less than 0. Same thing happened with Brie here. We are always actually increasing it, and then we're doing more increase afterwards. And the pass, again, the pass is doing some strange things, and we missed evidently a simplification we can make there. This is in fact, pass in update 3 is just setting the quality to 0. Just check we're right about that. Good. So given that we these other methods are just updating the quality, it seems strange that we have them in 2 separate places. So maybe it would be better to age the item first and then update the quality. I don't know why that's called update 3. Who knows? But if we try that and run the test, you see it fails. And let's have a look to see why it fails. It succeeds for quite a long time. It succeeds until day 5, and then the backstage passes start going wonky. And when we look at why that is, you can see that the backstage passes they update their quality, and then they update the quality depending on the cell in. But now we've moved this so that the cell in, we've moved this after we've changed the cell in. But we know what we do in the case of cell in is we reduce it by 1, so we could actually change this, I think, from 10 and this to 5, taking account of the change to the cell in that we'd made now before we called update 1, and that passes our tests. And that's quite nice, but it also shows the problem with mutating things and doing things with a time order. Everything else is happy though, so I wonder whether we should just merge update 1 and update 2. We can do this a long way or a short way, and my inclination is just to say, let's just cut this code out of here and put it in here, see how this does. In the case of Brie, I'm going to cut this code out of here and put it in here, and in the case of the pass, we're going to cut this code and put it there. That's quite nice. Again, if we had a larger code base, we might want to refactor that better, but that will do. So now we have update that's just composed of aging and updating, and I think we can think of this update then as degradation. So we change the age of the item and then we degrade it. So we're going to say degrade. Give it a name. So our code is now a little bit simpler. Each one of these methods is more complicated, but at least we don't have to worry about the fact that some things are happening after we've aged the item and some things are happening before we've aged the item. That feels like a good place to check in. Reorder methods and remove and merge update 1 and what we turns out we called update 3. Okay, little break. Before we go on, it might be worth sanity checking what happens with passes. You see here, because we actually changed these numbers, maybe we should go back to the source and find out whether that was a thing we want to do. And you can see here it says for backstage passes, quality increases by 2 when there are 10 days, by 3 when there are 5 days, drops to 0 after the concert. So there's 10 days and 5 days, and now in fact you can see we've got 10 days and 5 days in here. So actually in some ways this is a better expression of the requirements than the previous version that had 11 and 6 because it was looked at before the age had been reduced. Okay. Now when we look at the complication in here, there are all these places that we do a thing quality. So before we change the quality, we keep on asking something about the quality. In this case, whether it's less than 50. In this case, again, less than 50. But in here, whether it's greater than 0. And so what we're actually doing is we are ensuring the quality doesn't go outside these bounds. When we look at the requirement, it says the quality of an item is never more than 50 and the quality of item is never negative. And so that's been ensured here by making a check before we change the quality. I think that's okay, but it's complicating this code, it's complicating our ability to understand it. What we could say is let's let the quality change and then let's set it back to 0 or 50 depending on which way it went out. So let's put that in here. Let's say if the quality is less than 0, quality equals 0. And if the quality is greater than 50, let's set the quality to 50. Because if we get that right, that will allow us to remove lots of this irritating code, but we haven't got it right. And what we haven't got right is that sulfurous starts at 80 and shouldn't go to 50. How's that expressed in the requirement? Right down the bottom here it says, just for clarification, an item can never have its quality increase above 50, but sulfurous has its quality at 80 and doesn't change. So again, we've got a different requirement in the case of sulfurous, so let us express that as a protected method. We're going to call this saturate, and we're going to say that again this is a thing that one of our subtypes wants to do something special about. Move it in order down to the place it belongs. And what we know about sulfurous is that it doesn't saturate, it doesn't change. We might make it 80, but I think probably the sense is that a no-op is better there. Okay, that works, but now we can use it to simplify all of our code because we know that we don't need to worry about these little guard clauses. Take that one out, and that one, and that one. Left with that, reformat, run, that's good. And we just take these out. I wonder whether there is a better refactor for this, but it will do. Did we get that right? We did. Okay, so now we have actually better expressed something of the requirement. Previously it would have been possible to introduce another item with a special degradation policy which didn't check properly, didn't know about this 50 and 0. Now that's expressed in our superclass for us. It's expressed here. Subclasses can override it if it's special to them, but their default behavior will be that they saturate properly, which is good for us. So we have code that's closer to expressing the requirement actually in the code, which is good. So this is going to be introduce saturate. Okay, we're coming up on an hour of work here, so maybe just time to have a little tidy up before we take a proper break for lunch. Simplify a little bit. Let's have a look. In degrade here we are subtracting 1 and then we're subtracting another 1. I wonder whether that would be better expressed with an else. Move that down there. Check that works. And if it does, that's good. And we'll see later why that might be a good thing for us. Get rid of those braces really. Same sort of thing here. This feels like an else, and in fact that else might even be better as a when in Kotlin. So you can see that these are independent. We have the same thing in Brie where we're doing a thing and then more of a thing, so let's put the else in here. Format that, and we can check it runs, and it doesn't because we forgot to do that, and 2 in the Salian case. And now the same thing in the pass we are setting the quality to 0 final at the end. Otherwise we are adding in 1 to up to 3. So we can recast this as these aren't else's because they it does this one and then this one and then this one. But we could we can really write that as when let's think this through. When our quality, when selling is less than 0, we want to do this one. When the selling is less than 5, well, we'll have added 1, 2, 3 by then. So let's take this branch here. We're having to reason about this code in a bit of a nasty way. So we decided that was 3 we'd added, didn't we? Selling is less than 10. We want to add 2 to the quality. Not a good edit, is it? And then finally, else we want to add 1 to the quality. Reformat that. Take out these nasty ifs. Check that runs. And it passes, so we had the same logic. And now let's leave that alone for now. I think that's good enough. But in fact, IntelliJ is offering to list the assignment out of when. Quality is when that looks good to me. Okay, splendid. So this is just a simplification. We've avoided gratuitously mutating our items, and you'll see later on that comes in handy for us. So let's commit that. So just to review what we've done so far. We have introduced Kotlin to the project. We've converted parts of it to Kotlin. And then we've taken the opportunity to take a nasty single big procedural method and split that up into separate stages and then distribute those stages amongst subclasses so that subclasses of our base item that we introduced can affect the way that the algorithm works, where the top level expresses the structure of the algorithm and the individual sub-pieces reflect the details of that, where they want to override behavior. Now, this is still a little bit confusing. We're still updating things all over the place. We are mutating our base item. But it's not a bad OO solution. I think we can make it a better OO solution before we're done. And then before we go on to look at what a functional solution to this problem might look like. But those are for another video, I think. So I'll say goodbye now and see you with luck in the next video.